Trig Ratios, Part 3 by Jeff Simpson, MasteryLearningSystems.com. Naming the parts of a right triangle. Before we start naming the parts of a right triangle, here's some useful background information on isosceles triangles. The ancient Greek word skeles means leg. An isosceles triangle has two legs. Our legs are usually of equal length. The ancient Greek word isos means equal. So isosceles means equal legs. An isosceles triangle always has two legs of equal length. Question: what does a radius of a circle have to do with an isosceles triangle? Well, let's take a look. A radius goes from the center to the edge of a circle. All the radii are the same length. An isosceles triangle has two legs of equal length. Here's a circle with two radii of equal length. If you connect the radii with a line segment, you can make an isosceles triangle. What do you call a line segment that connects the ends of two radii? Well, here's two radii, and there's a line segment connecting them. Here's two radii facing a different direction, and they're connected by a line segment, and here they are in another direction. Now the radii have disappeared, and we just see these line segments. What do you call them? You call this line segment a chord. If you connect two points that are on the circle, you have a chord. It's from an ancient Greek word meaning the string of a lyre. A lyre is a harp-like instrument. So here's a chord, like one of those strings. Another word for chord is sine, which is often abbreviated as S-I-N, pronounced sine. So here's another chord, or sine. Sine actually comes from a Latin word which was a sloppy translation of the original Sanskrit word that meant bowstring. Here are two radii connected by a chord, or in other words, a sine. Question: what does an isosceles triangle have to do with a right triangle? Well, let's take a look. If you split an isosceles triangle right down the middle, this is called dropping an altitude, you get two right triangles. Here we see an isosceles triangle formed by two radii and a chord, or sine, being split down the middle by an altitude to create two right triangles. Started as an isosceles triangle, split down the middle, becomes two right triangles. When we erase one of the right triangles, we no longer see the whole chord. We only see half of it. After this, we will use the word sine to mean half of a chord. So at the end of the triangle you see a sine. Here we see three chords. Notice the line goes all the way from edge to edge of the circle. Now we'll see three sines. Starts off the same, but it stops halfway. So a chord will go all the way from edge to edge, but the sine stops halfway. Now, naming the sides of a right triangle. Here's our first way of naming the sides of a right triangle. You start with a circle in the center and you make a radius. Here's another radius, a chord, an altitude, right angle. Get rid of the radius, erase the chord, so we only see half of it. It's the sine. So the three sides are named sine, altitude, and radius. The second way of naming the sides of a right triangle requires further exploration of circles and lines. A circle has no corners, no sides, and no endpoints. There's no beginning or end. Not only does a circle have no endpoints, but in geometry, a line has no endpoints. The arrowheads on both ends of the line show that it extends forever in both directions. There is no place where it begins or ends, just like a circle. Now, if a line touches a circle at one point, it is a touching line. The Latin word for touching is tangent. So math people call it a tangent line, or just a tangent. The point where the tangent line touches the circle is called the point of tangency. You can use two tangents to make a right angle. The right angle is outside the circle. You can use three tangents to make a right triangle. Part of the triangle is outside the circle, and part of the triangle is inside the circle. You can use four tangents to circumscribe a square about a circle. There we see a square surrounding the circle. There are 4 points of tangency, 4 points at which the square touches the circle. When you cut the circle into 4 equal parts and move tangents in to touch the endpoints of those lines we cut the circle with, you get 4 squares. And at the 4 points where the tangents touch the circle, there will be a pair of 90-degree angles. There they are, right near the points of tangency. If you touch the circle with a tangent, and draw a radius from the center to the point of tangency, the tangent and the radius form a pair of 90-degree angles. When you draw a line from the center of a circle to the point of tangency, you create a right angle, 90 degrees. Wherever the tangent line touches, it makes a right angle when connected to the center. If you draw a tangent and a radius, and then erase the lower part of the tangent and the radius form a 90-degree angle. If you draw part of a tangent and a radius to form a 90-degree angle, you can fit a square in that space, or a tall rectangle, or a short rectangle. If you start with a tangent and a radius and a 90-degree angle, you can fit a square in that space, or a right triangle made from half of the square. You can fit a tall rectangle in that space, or a right triangle made from half of the rectangle. You can fit a short rectangle in that space, or a right triangle made from half of the rectangle. If a line cuts through a circle at 2 points, it is a cutting line. It's not a touching line, it's a cutting line. The Latin word for cutting is secant. So math people call it a secant line, or just call it a secant. Secant lines can cut through in any direction. You can use 2 secants to make 4 90-degree angles, right where they cross each other. The right angles are inside the circle. You can use 3 secants to make a triangle. The whole triangle is inside the circle. You can use 2 secants and a tangent to make a triangle. Part of the triangle is inside the circle and part of it is outside the circle. You can use 2 tangents and a secant to make a triangle. Part of the triangle is inside the circle and part of it is outside. You can make a right triangle from a tangent, a radius, and a secant. Tangent, radius, and secant. Part of the triangle is outside the circle. Naming the sides of a right triangle, our second look at it. Here's our second way of naming the sides of a right triangle. The tangent radius, and secant. Tangent, radius, secant. So let's look at two ways of naming the sides of a right triangle. First way, three sides are called sine, altitude, and radius. Second way, the three sides are called tangent, radius, and secant. Notice the radius is used in both number 1 and number 2. In number 1, the radius is the diagonal-looking line, and the whole triangle is inside the circle. But in number 2, the radius is the bottom of the triangle, and part of the triangle is outside the circle. With number 1, the vertical line is the sine, the half chord. The sine is inside the circle. With way number 2, the vertical line is the tangent. The tangent is outside the circle. The third way of naming the sides of a right triangle uses knowledge derived from squares, rectangles, and diagonals. The sides of a square are of equal length. And all the angles, of course, are 90 degrees. Draw a diagonal, then rotate the square, erase the lower part of the square, and you have an isosceles right triangle. There's one leg, there's the other leg, and they are of equal length. Two legs of equal length and one 90-degree angle. If we rotate a square and use the top two sides of the square, we have two equal legs of a right triangle. But what do you call the line that stretches under the two legs? The line that stretches under the two legs is called the hypotenuse. Hypotenuse comes from two Greek words meaning stretched under. Even if the line stretches over the two legs, it is still called the hypotenuse. When you make a triangle from a square, the diagonal of the square and the hypotenuse of the right triangle are the same line. It works the same with the diagonal of a rectangle. Here's a diagonal connecting the two corners. Two sides of the rectangle give us two legs of a right triangle. And the hypotenuse then stretches under the two legs. Notice, the two legs of an isosceles triangle are always of equal length. And the two legs of an isosceles right triangle are also of equal length. However, The two legs of other right triangles are not the same length, but they're still called legs anyway. The diagonal of the rectangle and the hypotenuse of the right triangle are the same line. The legs come from the rectangle and the hypotenuse is stretched between them. Here is our third way of naming the sides of a right triangle. The two sides that form the right angle are called legs, and the hypotenuse stretches between the two legs. The three sides are named leg, leg, and hypotenuse. Now let's review three different ways. We can call the three sides sine, altitude, radius, or tangent, radius, secant, or leg, leg, hypotenuse. The fourth way of naming the sides of a right triangle uses letters. To distinguish one leg from the other leg, one leg is labeled A, and the other is called B. So here's the two legs. We've got leg A and leg B. Or you could just call them A and B. Then there's the hypotenuse. So we have side A, side B, and the hypotenuse, or the hypotenuse is labeled side C. Or just C, yes. And the other ones can be called A and B. So the three sides now are named A, B, and C. This way of naming the parts of a right triangle is normally used when applying the Pythagorean Theorem. You might remember a squared plus b squared equals c squared. Here's an example of the Pythagorean Theorem at work. You see the two triangles, side A, and these are the same size. Side A is 3. You could make it 3 feet, 3 inches, 3 miles, 3 whatever kind of units you want. Side B is 4. Side C is 5. A squared plus b squared equals c squared means 3 squared plus 4 squared equals 5 squared. Well, 3 squared we know is 9. 4 squared, 4 times 4, is 16. 5 squared is 25. And yes, it's true that 9 plus 16 is 25. Here's another example of the Pythagorean Theorem. This triangle has a different shape, but it still is a right triangle. Sides A, B, and C. A is 5, B is 12, and C in this case we have 13. A squared plus b squared equals c squared. That would be like 5 squared plus 12 squared is 13 squared. Is that true? Yes, it is, because 5 squared is 25. 12 squared is 144. You add them together and you will get 13 squared, which is 169. So now we can look at 4 ways of naming the sides. Sine, altitude, radius, or tangent, radius, secant, or leg, leg, hypotenuse, or A, B, C. Now let's get into naming the angles. Up until now we've shown different ways of naming the sides of a right triangle, like naming them Alex, Billy, and Chris. No, just kidding. Naming them A, B, and C. Now let's look at ways of naming the angles. of a right triangle. Let's start with what we know about a square. With 90 degrees at each corner, a square has 360 degrees altogether. Cutting the square into two triangles, each triangle has half of 360. In other words, 180 degrees. When a diagonal cuts a square into two right triangles, each right triangle contains a right angle, 90 degrees. A triangle made from a square has a right angle and two angles that are each less than 90 degrees. There they are, which are called acute angles. Acute means less than 90 degrees. Acute comes from a Latin word meaning sharp as a needle. Traditionally, the two acute angles are labeled A and angle B using capital letters. And the right angle is labeled as angle C. The same is true of a right triangle made from a rectangle. If we start with the diagonal, we get two right triangles. Erase one of them. There are two acute angles that are labeled angle A and angle B. And the right angle is angle C. Side A is opposite angle A. Side B is opposite angle B. Side C, the hypotenuse, is opposite angle C, the right angle. So in naming the angles, we could name them acute, acute, and right, or we can name them angle A, angle B, and angle C. Sometimes only one acute angle of a right triangle is named. It is often labeled as angle A. When only one acute angle of a right triangle is named, it is sometimes called theta, which is the 10th letter of the Greek alphabet. Theta looks kind of like a zero with a bar through the middle. Now we have four ways of naming the angles of a right triangle. They can be called acute, acute, right, or A, B, C, or one acute angle is named A, or one acute angle can be named theta. Now let's explore the acute angles. The diagonal of a square cuts the 90-degree angles in half, and each acute angle is 45 degrees. The two acute angles add up to 90 degrees. In this example, 45 plus 45 is 90. Two angles that add up to 90 degrees are called complementary angles. The three angles add up to 180 degrees. The right angle has 90 of those 180 degrees. 180 minus 90, that leaves 90 degrees for the other two angles. The two acute angles, A and B, must add up to 90 degrees. In other words, angles A and B are complementary. Complementary comes from a French word that means making complete. Here are more examples of complementary angles. This acute angle is 60 degrees, the other one is 30 degrees. Those two add up to make 90, so they're complementary. In this triangle, we have 50 degrees and 40 degrees for the two acute angles, and they add up to 90. 45 and 45 add up to 90, and 40 and 50 are complementary also. Acute angles A and B are complementary. They add up to 90 degrees. So you can say that the complement of angle A is angle B. Or looked at the other way, the complement of angle B is angle A. The abbreviation for complementary is CO. Sometimes we refer to a person without using their actual name. For example, we can say Bert and his friend instead of saying Bert and Ernie. There's Bert and there's his friend. Similarly, we sometimes refer to an angle without using its actual name. For example, we can say 60 degrees, that's one of the acute angles, and the complement of 60 degrees. In other words, 30 degrees, because 60 and 30 make 90, which makes them complementary. Or we could say angle A and the complement. Here's angle A, and there's the complement. A plus complement equals 90. Three ways of naming the acute angles. First way, A and B. Second way, A and its complement. Third way, theta and its complement. Now, a little bit more about naming the sides of the right triangle. There are two more ways of naming the sides of a right triangle. We have the two legs, of course, that form the right angle, and the hypotenuse, which is always the longest side of the right triangle. If we look at the two legs from the perspective of angle A, one leg is on the opposite side of the triangle from angle A. So we call it the opposite leg. The other leg is adjacent to angle A, right next to it, so we call it the adjacent leg. Looking at the triangle from the perspective of angle A, we can also refer to the opposite leg as the opposite side. And the leg that is adjacent to angle A can be called the adjacent side. The hypotenuse, of course, already has a name. Angle A's opposite leg, or opposite side, is usually abbreviated as just as the opposite. Angle A's adjacent leg, or adjacent side, is usually abbreviated as just the adjacent. What if we look at the two legs from the perspective of angle B, the other acute angle? Well, angle B has an opposite leg, or an opposite side. And angle B also has an adjacent. the hypotenuse is still in the same place. Angle B is the complement of angle A, so we can label the sides as, if we're looking from angle A's complement, the complement's opposite, and the complement's adjacent, and the hypotenuse is still the longest side. Now, let's look at 6 different ways of naming the sides of a right triangle. Here's angle A, and we have its opposite, adjacent, and hypotenuse. Or, from the other perspective, from A's complement, there's the opposite, adjacent, and hypotenuse. Ways number 3 and 4. Leg, leg, hypotenuse, A, B, C. And from much earlier in the video, using a circle, we have a radius, a tangent, a secant. We erase the extra parts of the tangent that we don't need, erase the extra parts of the secant, and we have tangent, radius, secant. And one other way, we start with a radius, a chord, another radius, the altitude, which makes a right angle. Erase half of the chord, so you just have a sine. Get rid of the extra radius that we don't need. And we have sine, altitude, radius. Well, you've seen many ways of naming the parts of a right triangle. We have tangent, radius, secant, opposite, adjacent, hypotenuse. Each way has a good reason for existing. You're now ready for the Part 4 video, where you'll see all these part names come together to make trig ratios. Thanks for watching my video. Please share these ideas with people who can benefit from them.